Okay, well, welcome everybody to this meeting of the virtual CICS user group. Slide that along. Yeah, I'm Trevor Eddles. I'm CEO of iTech Limited. We're a mainframe consultancy, analysis and technical authoring organization. And we're the people responsible for the content on the virtual CICS website. And we produce the newsletter. The website, if you haven't been on there yet, can be found at virtualcics.hostbridge.com. Anyway, let's start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation, and today our guest presenter is Stewart Francis, lead software engineer at IBM, and he's going to be discussing developing and modernizing CICS applications with Ansible. And he might even have a couple of demos to show us at the end. A copy of his slides will be on the website later today. And if you missed our previous meetings, you can download copies of those presentations from our website too. And you can listen again to the whole presentations. The link's on our resources page. So that's virtualcics.hostbridge.com/resources.htm. Following Stu's presentation and any questions you have for him, we'll move on to the latest CICS news and the latest CICS-related articles. And then I'll give you the dates and times for the next virtual meetings. So that's the plan for this meeting. And I'm anticipating that it will last for about an hour. Let me just admit a couple more people. Anyway, as I just said, today's presentation is from Stewart Francis. Stu is the CICS TS developer productivity architect. He works for IBM in Hursley Park and has been working on CICS TS for 15 years. Stu works on a wide variety of CICS productivity tooling like CICS Explorer, Java developer tooling, and the CICS TS Ansible collection, which is what he's going to be talking about in this session. So Stu, I'd like to thank you very much for being with us today. And what I'd like to do now is pass control of the meeting over to you. So I'll stop sharing and you should be able to share your screen.
Perfect. Okay, is that working okay?
Yep, can see that, that's good.
Great. Okay, thanks for that intro, Trevor. So I have spoken on one of these meetings in the past. Trevor and I were just chatting about it before. I think it was about 2 years ago, talking about some of the improvements we've made to Java developer experience. For the last kind of 5 years of my career, I've been looking at how we can make solutions in CICS TS to make it more productive for developers. Before that, for about 10 years before, I was the lead engineer on CICS Explorer, and I still get my hands dirty with CICS Explorer, probably more often than the team that's working on that would like me to. But yeah, I still get involved with CICS Explorer things as well. The year before last, we released the first version of our brand new CICS collection for Ansible, to help you better integrate CICS TS in your DevOps pipelines if you're using Ansible. So I'd like to talk to you a bit about that today. I'm going to start with an introduction to Ansible and why it might be interesting for people on ZOS. One of the really nice things about Ansible for Z is that it's not just CICS who are pursuing this agenda. We have great Ansible collections for manipulating ZOS resources. I'm going to talk about that a bit, and for a number of other subsystems on ZOS, and I'll kind of give you a very brief introduction to those as well. And then we're going to finish up with some demos of showing the CICS TS Ansible collection in action, and how you can combine it with other Ansible content like the ZOS core collection to produce a concerted automation solution as well. So Ansible is a very general purpose automation tool. Its tagline is you can use it to turn tough tasks into repeatable playbooks. Playbook is a term you'll see a lot when you're talking about Ansible. It essentially is an Ansible script that you're going to run against some target systems. Ansible is not a ZOS specific technology. It's an open source automation platform that's used very widely across the entire industry for producing automated solutions for a huge host of different environments. You can use it for managing Linux hosts. You can use it for managing ZOS. You can use it for managing Windows environments. You can even use Ansible to automate state transitions on network hardware and platforms that might be really difficult for you to automate. And part of Ansible's appeal is that it can be a ubiquitous automation solution that you can use right across your enterprise. What makes Ansible different from just writing automated scripts that you might have approached normally is that Ansible models your entire IT infrastructure. And when you run a piece of Ansible automation, you are describing a state transition you want to happen in your infrastructure. And that is very ingrained into the system. You're not just going to be telling a procedural piece of automation what to do. You're going to describe the state transition you want to happen. And the Ansible runtime is going to apply that state transition to a number of systems simultaneously to get your entire infrastructure to your new desired state. At least that's the idea anyway. What is important to bear in mind is that Ansible is a very general purpose automation solution, and you can essentially treat it like a scripting language. In fact, as we'll see, there are ways you can run scripting languages or interpreted languages like Python embedded in Ansible scripts, so you certainly can treat it like that. So the way you choose to implement your automated solutions is up to you. What I kind of mean to get at with all of this is it is incredibly flexible. And for me, it's certainly one of those tools that, when you have a hammer, everything starts looking like a nail. Ansible is flexible enough that when I start looking at all these, I keep seeing problems that I'm like, I could automate that with Ansible. So there's a lot of things that for me on ZOS fall into that category of I'm not sure how I would have been able to do that without Ansible, and I can chain a whole bunch of things together and have one tool that I can run that will produce some automated solution. So I've said that Ansible is, I'm going to say Ansible a lot in this presentation. I kind of realize the further on I get in it as well. I must have said Ansible like 200 times. It's commonly used for these kind of scenarios: system provisioning, configuration management, things where you're affecting state on remote machines. One of the really popular applications for it is doing things like managing certificates. So when you have a bunch of SSL certificates deployed on remote machines and you need to deal with certificate expiry, updating those stores with new versions, Ansible is a really nice tool to do that, because you can do that across a whole bunch of systems as one kind of automated solution. Managing users as well is really popular, but it is general purpose. So anything you can think of, you can probably think of a way to do it. The best way to kind of get your head around that is you can use Ansible as well as a raw tool for performing your automation. You can also think of it as a kind of automation orchestrator as well. You can always use Ansible to run some existing piece of automation you have. So if you're on ZOS, you have some automated process that's a piece of JCL or a Rec script, or maybe you have a ZOS&F workflow or something in system automation. You could use Ansible to drive one of those, or to drive one of those and then the next one of those. So you can use it as an orchestrator to tie existing pieces of automation together, as well as having raw automated solutions that you've implemented in Ansible as well. And there are actually some collections that we have for ZOS to make doing things like driving ZOS&F and system automation easier. Hopefully you're getting an idea of why Ansible is so popular. It is no kind of word of a lie that it is a very popular solution across the industry for producing automated solutions. One of the kind of interesting ways of getting your head around how popular it is, the Ansible main repository on github.com used to be the ninth most popular repository on github.com by number of independent committers. Part of the reason for that was that the way that you contributed third-party content to the Ansible platform, say you wanted to produce an Ansible automation like we have for ZOS, or you want to produce an Ansible automation to make it easier for people to produce solutions for Google Cloud or AWS or something like that. All of those contributions used to go in the Ansible main repository, and they actually changed that contribution mechanism a few years ago. Obviously, all those commits are they still count as number of independent contributors, but now you'll find that the third-party content all goes in its own separate repositories. And there's an organization on github.com called Ansible Collections, and you can go in there and see all the ones that are open source. So you can see all the source code for those collections in there. That's no longer in the Ansible repository, but for example, the 8th most popular GitHub repository, so one place above Ansible on that list, was Kubernetes, and I'm sure everyone has heard a lot about Kubernetes in the last few years, so gives you a kind of idea of how popular it is. Some of the reasons for that are that you can normalize your tooling across all these different platforms because you can use Ansible ubiquitously. And then that allows you to have some centralized automation strategy where you can run an automated process that's going to make state changes on a bunch of different systems with different architectures all at the same time. Obviously, this sort of thing allows you to achieve configuration as code. So things that you had previously struggled with getting into some kind of source code management, so that you don't have to rely on a manual process or a manual documented set of steps that you have to follow for something to happen. You can capture that state in source code, so you can version it, and then you can rely on the automated process to make that state change happen. The time I wrote this slide, which is quite a long time ago now, every time I get to this slide, I bet that number's a lot bigger now. At the time that I wrote this slide, there were over 3,000 community modules for things you'd like to extend with Ansible. And now, since that number was put on this slide, I've been involved in 5 of them. So it's at least 5 higher than 3,000 now, but probably significantly higher than that. One of the great things about Ansible is, we'll talk about this a bit in a minute, but there is infrastructure that can make Ansible easier for you to get started with. For example, there's a kind of automation as a service platform called Ansible Tower, which can host automation for you, so you can log in and run a job, run some automated process with role-based access controls and stuff like that. If you're looking to use Ansible, then it's quite likely, if you ask around, that you'll find that you already have an instance of that running. You can benefit from that already being available to you. So it's worth asking around, and you might find there are other people in your enterprise who already have a lot of skill. One of the things we found for Ansible, that it is something that you'll find that people already have, like they'll know how to do, and you can combine that knowledge with the domain knowledge that you still need for Z and you still need for your middleware to produce these automated solutions. So you can kind of work together as a team to achieve that. And you'll also find that because Ansible has this big community aspect to it as well, there's loads of really easily Googleable information about how to produce automated solutions. If you're stuck with something in Ansible, you can Google it. It's the sort of thing that you're going to find answers on Stack Overflow saying, oh, you should do it this way, and then they'll have 50 upvotes, and you'll be like, well, that's probably the way I should do it then. So that community aspect of it is really powerful as well. So one of the things that makes Ansible a little bit different from other automation solutions is that Ansible has this, what they call an agentless architecture. What that means is you don't have a process that's running on all of your target systems that's waiting for you to dispatch some work to it. So waiting for you to, and then you have to have that agent pre-configured on all of your systems. Ansible, all it relies on is a way of communicating with these target systems. When you actually run the piece of Ansible automation, it runs on a node in this network called the control node. Sounds very highfalutin, but what I actually mean for the purposes of the demos we're going to get to later, the control node is going to be my laptop. It's just the machine, the thing that's running the Ansible runtime. But that isn't necessarily the thing that you're running automation against. That control node is going to communicate with all the remote systems that the state change needs to happen on. What happens and what's going to happen for the purposes of this demo, and this is broadly speaking true of the way that all Ansible modules work, or a lot of them. The control node is going to send a payload over SSH to those remote systems. That payload is going to be something executable. It's going to run on those systems, and then it's going to build, so to achieve some state change that you described, and then that's going to build some response on those systems and send that back over that communication channel to the control node. For the purposes of this demo, and for almost everything you'll see, that communication method is going to be SSH. And for the purposes of the modules that I'm going to be showing you, and again, the most common way of doing this, the payload that we're going to be sending is going to be a Python script. Ansible provides the reason that's so popular is that Ansible's main SDK for developing modules is a Python library, and that produces a Python executable payload which gets sent over SSH and runs on that remote system. So because Python is an interpreted language, you need a Python runtime installed on those systems. For the COS collections, we're going to be talking about IBM Open Enterprise Python version 3.8. So whilst it's agentless, there's nothing running on those remote systems waiting for things to happen, there are some prerequisites that you need to set up. So you'll need to have IBM Python installed in Unix system services to be able to use some of the Ansible modules. And some of the other modules may have their own prerequisites too. For instance, if you want to use the COSMF module, you'll need COSMF. That sounds like a bit of a redundant statement. There are other modules which have other utilities that you need to have pre-installed as well, and we'll get onto the details of that later. In terms of what Ansible has to tell you about what systems it's going to run against, that is a concept called Ansible's inventory. So when I run Ansible on my laptop in these demos, I'm going to have a file, which is my inventory, which is going to tell me which remote systems I'm going to be running against. That's essentially, for this case, going to be a list of host names. And in the example I've got on the right-hand side of this slide, they're divided into groups. So I can choose to run a piece of automation against an individual host by binding it by identifying it by host name, or I can run a piece of automation against a group of hosts by identifying that group, or I can run a piece of automation against all of the hosts in my inventory as well. Ansible is a very extensible platform. You can provide custom modules that do custom things. We'll talk about what that means in a minute. But you can also customize a lot of the things about how Ansible builds up its idea of what the state of your system looks like. One of the ways you can extend Ansible is you can write a custom inventory plugin, and that allows the inventory to be dynamically provided. So rather than having to have a file, you could write an Ansible plugin, which will go away to your target, which will look at some other file format or contact some API and grab information about the hosts that you want to write, that you want to run automation against, and classify them into groups. And you will find that for a lot of things like the big cloud providers, there are already inventory plugins for Ansible to capture the existing real estate that you have deployed, so that you don't have to manage a static file as well. So I said in one of the earlier slides that there are over 3,000 modules available for Ansible community extensions. Modules are the things that implement Ansible tasks. So when you build your piece of Ansible automation, you're effectively going to be writing a sequence of these tasks, and the tasks will know how to do something to some remote machine. So the configuration for these all goes in one big YAML document, and we'll see some examples of that in a minute. There's a fragment of this on the right-hand side, which shows how you'd configure an individual task. The task we are configuring on the right-hand side here is the shell task. That is a task that's built into Ansible. So that comes with Ansible. When you install your Ansible runtime on your control node, then the shell task will already be there. There is a kind of package management system for Ansible where you can install other things that don't come with the Ansible runtime itself. When you configure all of these tasks, they'll all have configuration which is specific to them. So you'll need to know what the parameters for those are. All of the tasks, actually all the built-in tasks, but all of the community tasks as well, when you publish them to Ansible's repository, there are reasonably strict checks on making sure that you've provided documentation for all the options and specification for like what format the options have to be in and things like that. So you will find that the documentation for these tends to be pretty good in terms of describing what options are available to you. The shell task here that we're just saying, change directory into this directory and then run the following command. So pretty obvious configuring that one, others maybe less so. Then those tasks get composed into a larger automate, and this is the thing that you can think of like as an automation script, which is a playbook. I guess that's an NFL analogy. You have here a playbook, and the playbook is not quite as simple as a list of tasks. Whilst you do have a list of tasks in it, you also have some other important pieces of information at the top, not least of all, which hosts we're going to run this against. So that hosts part on the right-hand side is identifying either an individual host name or a group of hosts from my inventory. So that, in this case, web servers would be the name of a group from my inventory. And then all of the tasks are going to get run against those hosts. There is some flexibility about how you do this in Ansible as well. So you can bind an individual task to a different host. You can bind a block of tasks to different hosts. And you can provide the name of the hosts that you want to bind the playbook to dynamically as well. So you don't have to have it statically coded in the playbook too. Then when you execute the playbook, Ansible is going to run each task against each system that the playbook is binding that task to. So for every web server in my group of web servers here, we're going to go through each of those systems and run each of the tasks against them. There are a few ways you might think of running a playbook. The way I'm going to do it in these demos is I'm going to use the Ansible CLI. That comes with the Ansible runtime when you install it. Gives you a command you can type called Ansible-Playbook, and there are a few parameters to that I'm going to be using. -I is the name of your inventory file. So I'm going to be using an inventory file, it's just called databases here. The last argument is the name of the playbook that you're going to run. You'll notice that is in the YAML format, as we saw from the examples. And then -E allows you to override variables on the command line. So when you're executing your playbook, you can override variables. And I'll show you some examples of what variables look like in Ansible playbooks too. This is what I was alluding to before when I said you may have some Ansible infrastructure in your enterprise that might be useful to you. The screenshot on the right is from a Red Hat offering called Ansible Tower. Ansible Tower is a service you can run to provide automation to other people. So you can aim it at your repository with your Ansible playbooks in, and you can provide role-based access to those playbooks as well. So you can say, based on certain groups of people who are able to access this, and you can do running as with different authority as well. So if you want to provide a piece of automation, you want to secure it so your developers can use it, they don't have access to all of the things that the playbook can do because it's going to switch authority and actually run with someone else's authority, you can have Ansible Tower provide that kind of delegation authority there as well. And it also does a whole bunch of other things like record the history of previous executions and scheduled automation runs and dashboarding and things like that as well. So there's a whole bunch of interesting stuff in there too. So if you already have an instance of Ansible Tower, then it's a nice way for you to be able to get started with sharing your automation solutions with your colleagues. You can write your playbook and then have it hosted by Tower so that everyone can benefit from running it. So why would you want to use Ansible on z/OS? It allows you to centralize your automation skill set around the same sorts of technologies that you might be using elsewhere in your enterprise, reuse those existing pieces of infrastructure that you have, and unlock opportunities for collaboration that way. I think the really interesting thing for me is the amount of flexibility you have. And an example of that for me, this is one of those like when you have a hammer, everything looks like a nail. I was working with one of the teams here in Hursley on a new feature that's in CICS 6.1, which is called security request recording. And the idea behind this feature is that for a given transaction in CICS, you can turn on some form of trace for your security requests. So if you have a security problem that someone's reported and you want to know where in that application there's been a security check that's failed and you want to know why that check failed, then security request recording is a really interesting solution for that. So what you do is you enable it at the entry point for your transaction, and that sets a flag on the transaction that stays with that transaction wherever it goes. So if you link to a different system, you switch to a different user and you run a different transaction, that will maintain that state that security requests are being recorded and all the information gets written back to the same journal. There's a really good demo of this using CICS Explorer, where you enable security request recording, you trigger it, and then at the end of that, when you've captured all the information to your journal, you need to extract the information, and there's a new utility program we provide with CICS, which can take that information and convert it to a CSV file, which you can then download from the mainframe, open up in something like Excel, and you'll see really detailed security analysis of this, of that transaction, and you can see like really detailed information out what was checked, why it failed, and so on. But that was obviously quite a lot of steps, and it was a really interesting exercise to be able to automate the whole thing. In Ansible, it's not so good when you're trying to do a live demo of it because the Explorer demo looks much more complicated because you're going through a lot more steps, and the Ansible demos over in about 30 seconds. But it's a good illustration of how you can make that process, that sort of thing that would be really difficult to automate before, because you're needing to make changes to CICS, you're needing to make changes to your z/OS resources, you want to download files to your local file system, things like that. And Ansible you can use for all of those. So you can make one script that runs quite quickly that does all of this stuff. So there is now quite an extensible set of Ansible automation solutions for z/OS. The online website you go to find out about Ansible automation is called Ansible Galaxy, and that is a repository for third-party contributions to the Ansible platform. And there is a command line tool you can run. I actually have done this bit already, so I won't be demoing it. But if you want to use some content from a collection that's hosted on Ansible Galaxy, once you've installed the Ansible runtime, then you can run a CLI command that comes with that called Ansible Galaxy, and that will pull this third-party content and integrate it into your Ansible runtime so that when you try running your Ansible script, it'll have access to it. So interestingly, like a nice way to think about this is that Ansible itself never runs on the target nodes. It only ever runs on the control node. So when we're talking about Ansible automation for z/OS, Ansible itself never runs on z/OS. These third-party collections, they never get installed on z/OS. All that happens is you add all this content to your control node, and that's used to build that payload that's going to make the state change on the remote system and get transferred across. And that's a really interesting approach, the fact that all of that management happens on the control node, because it means you don't have to manage all this third-party software installation on all the target nodes. It all just happens in one place. In addition to Ansible Galaxy, there's also a it has a lot of the same content as Ansible Galaxy. It's called Ansible Automation Hub, which is part of Ansible Automation Platform, which is a Red Hat offering. And this is a pay-for service, but the distinction between this and Ansible Galaxy is that the collections that you can get from Ansible Automation Hub are the service process for those is managed by Red Hat. So your service engagement, if you have any problems with using any of the collections that are on Automation Hub, you will go through the same process for all of them. And that means you can consider all of this open source software without having to have separate agreements with all of the people who offer these different components that you'd like to use in your automated solution. You can just have one service engagement with Red Hat, and they will manage that relationship with all of the other teams for you. So in order to get your content hosted on Automation Hub, you have to have an agreement with Red Hat for that service engagement. And almost all of the ZOS content that you'll find on Ansible Galaxy is also available on Ansible Automation Hub as well. So and the screenshot on the right is showing some of the other collections that are available. I'm going to be showing some demos of our collection from the CICS, which is called IBM ZOS CICS. You also have the IBM ZOS Core collection, which has really great foundational ZOS automation technology in it. So you can use it to do things like allocate data sets, run jobs, query JES for job output, run operator commands, etc., make changes to the Unix file system. And then there are also Ansible collections for INS, system automation, and ZOSMF. So you can use the system automation and ZOSMF collections to trigger existing pieces of automation that you have there as well. So our CICS collection for Ansible, I mentioned there is a new repository, new-ish, it was new last year, new organization on github.com for third-party Ansible content, and that's where our source code for that is. So it's being developed as an open source project under the Apache license. So that's github.com/Ansible collections/IBM ZOS CICS. On the Galaxy website, we're at galaxy.ansible.com/IBM. You'll find all the ZOS stuff by us under IBM, and as is IBM ZOS CICS there as well. Our collection it is part of the supported Red Hat certified content, so that means it's also available on Ansible Automation Hub as well. And so with all of the slides covered, I'm going to try and show you some demos of Ansible running on my laptop as a control node. And hopefully that'll get you thinking about how you could use Ansible as well. Our CICS collection is at the moment we have these 5 tasks in our CICS collection, and they are all tasks which are used to drive our CMCI REST API, which comes with CPSM. You can also run it in individual CICS regions as well. But the reason we chose to do this is because the CMCI API can make a huge number of state changes to your CICS configuration. So you can use it to define new programs and new transactions. You can use it to enable and disable existing resources. You can use it to new copy programs, and we'll see an example of that. You can use it to manage definitions in your CSD, so you can install CSD groups, or you can delete CSD groups. You can query your system for state to produce reports, and you can use it to do things. And almost any action that you can. A good way to think of it actually is if you've used CICS Explorer to do that, then it's probably also available for you to automate with our Ansible collection as well. And that actually applied to that security request recording demo I was talking about. All of the new functionality for enabling that went into the CMCI API so that we could drive it from CICS Explorer. And that meant that as a byproduct of that, you're also able to automate it with Ansible. So that's the reason we chose to do CMCI in our starting implementation of our CICS collection, because there's so much stuff you can already do. And this makes it really easy to do in Ansible. So you can kind of think of Ansible as a way to script CICS resource definition changes. So I'm going to show you a few examples of how that works, and hopefully should have time to give you a little bit of a guided tour of how you install Ansible as well. So the first scenario that I like to cover, actually the first two demos I'm going to show you, we have an online samples repository that's shared for all of these EOS content for Ansible. So you can go and have a look in there. There's loads of great samples for these EOS core collection and all of the other collections that are provided by IBM for ZOS. I'm going to show you a couple of our samples, and this first one's one of those. We're going to be looking at a scenario where if you're using CICS Explorer and you want to produce a report of some information, let's say it's information about CICS regions, you want to capture some information from one of those tables using CICS Explorer, and you want to produce a report in Excel so that you can save that information and send it on to some of your colleagues. You can certainly do that with CICS Explorer today, but in order to do that, you have to, open CICS Explorer, connect to your target system, open the right view, get the right attributes in there, sort them the way you want, copy everything, paste it into Excel and save it. And automating that across those different applications can be quite difficult to do. So because we have access to the raw data in Ansible, because it's all available on Explorer, it's all available on CMCI, we can now write an automated script that does that. So I'm going to be using VS Code to show you how that works. And the reason that I'm going to do that is because VS Code has a really great Ansible plugin. If you've looked at using the Ansible plugin for VS Code before, there is a newer version of a VS Code plugin for Ansible now, which is a lot better than the old one, has really great support for content assistant, things like that. So if you haven't checked out the newer version of the Ansible plugin for VS Code by Red Hat, that's really good. What I have here is I've just cloned our Z Ansible collection samples repository. So if I flip over to my web browser here, then in this tab here, so this was the link, there'll be a link to this in the slides. This shows you where the Ansible collection samples repository is. If you want to clone this, then same as usual, you go over here, grab the URL, git clone, paste that. You'll get all of that content the same way I've got it here. Then I've just opened that repository in VS Code. We're actually going to be running samples from the CICS section of this repository. You scroll down and here there's a README and there's a little guide. We're going to be down here in the CICS section. If you want to navigate through the file structure on your machine, you just go into ZOS subsystems, CICS, CMCI, and we're in there. And there's actually a README at this level as well. This samples repository is really good. There's loads of really great stuff for all of the different Ansible collections that we have on Galaxy in the Automation Hub. And they're all really well documented as well, that take you on a kind of step-by-step process for going through those samples. So we're going to be doing this retrieving operational data from running regions sample here. You go into here, there's a README for this sample, and it'll tell you all the steps you need to go through for doing that. For this one, there's also some things to think about next. This is a really nice way of thinking about getting started with Ansible for ZOS. One of the reasons I like to use this as the first example I give is that the picture I painted at the start, where you have your control node and that has Ansible installed on it, and you're going to ship modules, Python payloads over SSH to the target system. Because we're running against a REST API, we actually don't need to do that for the CICS collection. So instead of shipping the payload to the remote system, we're going to use this feature of Ansible called delegation, which means you never actually have to install Python on the target system. You never have to install any of those. You never have to have an SSH daemon. You don't have to set up any of that authorization. You do have to install Ansible locally. So I already have Ansible installed locally. So what I've got open here, if I come in here, we're looking at this reporting sample. This is the report sample we're going to run. So the VS Code Ansible plugin is what's providing all this syntax highlighting and validation here. All of the samples have a little bit of the README reproduced in here, so you can understand what the sample's for. As you're looking through the code, it's best to have the README open in another window as you work through them. This sample is really nice because when I run it, I don't have to edit anything. I can just clone the repository, try running the sample. It's going to prompt me for all the information I need, and then I won't have to make any other changes. Some of the other samples we're going to go through, there'll be some things that you do have to edit, but this one is a nice one to get started because there's no setup. If you're already running CMCI, if you're already using CICS Explorer, you'll be able to run this sample. You just install Ansible locally and get going. So Ansible itself is a Python library. So it's a Python application, and you install it from a remote repository called pip. And the way you install it is pip install Ansible. I've already done that. So you install Python. Python comes with the pip package manager now. Pip install Ansible will install the Ansible library into your Python runtime, and it will provide the Ansible CLI commands in your terminal. So I'm just using the integrated terminal in VS Code. This is exactly the same as using my other operating system terminals. If I use this one here, that would be exactly the same. So I already have Ansible installed. To run this playbook, I am going to run Ansible-playbook report.yaml. And then the rest I should get prompted for. So I'm going to point this at one of our CICS systems in Hersley. I'll run it, and then I'll talk through what happened. So providing my connection details, these are exactly the same sort of thing that I put in CICS Explorer, hostname port, whether it's HTTPS. And then this system's actually unauthenticated, so I'm not going to need the username and password. So when you run your Ansible playbook, you'll get this log produced, which will tell you everything that it did. Obviously, this by default puts out quite a lot of information there. I'm going to skip to the end and show you what happened, and then I'll talk through how I did it. So what that playbook did when I ran it is it generated this file called report.csv. And what that's done is extracted a bunch of information about my CICS regions from my CVSN CICSplex. And I can open this CSV in something like Excel to see it nicely formatted here, where I get my column headings along the top. So this is the name of my CICS region. This is what CICS release is running, the job ID, total number of tasks, etc., etc. Now, all the information in this report is customizable, so you can choose to pick out different information if you want. And that's one of the exercises we suggest to try out. So if we go look at the report, this bit at the top, if we look at the playbook, sorry, this bit at the top is the bit where we're telling Ansible to ask us for those parameters up front. So that's what made all those pop-ups happen. Doesn't have to work that way. You can have those hard-coded. You can actually put that information in your inventory. You can hard-code it into your playbook. And there are other ways of providing those variables as well. But you have a lot of flexibility there. I've also set up a variable here, which is not prompted for. So this is hard-coded in the playbook, which is the list of attributes that I want to include in that report. So these are the names of those CICS resource attributes that you will see in CICS Explorer. If you want to play with this and try getting this report to use different attributes, there is a debug statement we have here, which dumps the raw data before it formats it as a CSV. If you scroll up in here, you'll be able to see all of the attributes you could pick. So it's the attribute name and the value. So, for example, we can pick RLS status, and we could add it to the list of attributes here. And then next time we run this playbook, our report will have that extra information at the end. Here is where we actually invoke our task from the IBM ZOS CICS collection. So I previously installed that CICS collection locally by running the Ansible Galaxy collection install IBM ZOS CICS command. So that's already done, and that means my Ansible runtime has access to that collection. I have to declare that in my playbook. So up at the top, I'm declaring that I'm using the IBM ZOS CICS collection. And that provides access to this CMCI get task. So this is the CMCI task runner collection, which just gets raw data from the CICS regions. We pass through the parameters. So this is how you refer to variables in your Ansible automation with this double bracket syntax, double brackets and single quotes. And this type here is the CMCI resource name. So that's the equivalent of something like CICS region like that you might have seen elsewhere. If you want to know how these names correspond to the CMCI resource names, then there is some information in our doc about how to work that out. Then we save the information in this variable called result. Then we have the debug statement, which prints the result out, and that causes all this green text that you see down here. And then the last thing we do is we create a CSV report from that template. From a template. So the template is this file here called csv.j2. This is a templating language that's built into Ansible called Jinja. It's Jinja. The template is here for posterity. Not going to go through it, but essentially just loops over the data that we dumped in raw, prints out the attributes, then picks out those attribute values from the responses and prints those out, comma separated, with a new line in between each one. So you end up with a CSV file that you can open up. And then I've made a change to that. So if I run again, and you'll probably find if you try running this, that you get sick of typing those in. So the first thing that it is good to do is try hard coding those variables in your playbook or put them into your inventory instead. And then when you run that again, if I look at the report again, oh, I didn't save it, so it ran the same. Yeah, if I'd saved it and then run it again, which I won't go through typing everything in again, we'd have got more information in the report. So the other demo that I'd like to go through today is this deploy program demo. Now, if we look at the playbook here, which is this deploy program file, then this one is a bit more interesting. As well as using the IBM ZOS CICS collection, we're also using the IBM ZOS core collection. Hopefully this does a good example of showing you how you can use these two collections in concert to produce some concerted automation solution that does a bit of changes to your ZOS resources, a bit of changes to CICS, and it's really easy for you to share that piece of automation so that anyone can run it. So what we're going to do in this sample is we are going to this is obviously a little bit naive, but we are going to pretend that we have a PDS on ZOS, which has our compiled load module in it that our build system has just put there. And we want to copy that load module into a load library for one of our running CICS regions. And then we want to find the corresponding program in that CICS region. We want to run a new copy or a phase in to make sure that the next time that program gets executed by CICS, it's going to pick up the latest version of that load module. What's different about this one is we can't just run everything on my laptop. At this point, to run this sample, you have to have set up Python on ZOS. You also have to install one of the prerequisites of the IBM ZOS core collection, which is called Z Open Automation Utilities. Z Open Automation Utilities is a it's a collection of binaries that run in Unix system services that provide access to ZOS resources from Unix system services land. So it provides a consistent way for Unix system services applications to do things like submit jobs, get job output, run operator commands, etc. And that's the thing that powers a lot of the ZOS core collection. which is Python wrappers around the features that are provided by ZOS Core. I'm not going to go through the installation process, but I have done it myself, and it's not too bad. Once you've done that, you also need to set up SSH access to your target system. So I have set up passwordless SSH access using RSA key. So I am using authentication. The way that works is Ansible will look in your .ssh directory locally for the key information, for your private key to use to establish that encrypted communication tunnel with the remote system. So I've already set that up. And what that means now is that I have to have an inventory. So if we look in my inventory here, I'm running against, this is essentially the same system that I ran the previous sample as. We're going to connect to winmvs2c.hosby.ibm.com. What that means is Ansible is going to establish an SSH connection there. It's going to run as me, and then the Python interpreter is going to run to do stuff. It's called Python. If we go back to the playbook, I'll take you through the steps this playbook goes through. So a lot of these variables you're seeing here, so this is the name of my data set. So a lot of these variables in this sample, rather than the previous sample, which prompted me for them when I ran it, and I filled all the information in the terminal, all of this information is provided in host files, and that is essentially an extension to your inventory that allows you to provide per host variables. I'm not going to go into that now, but if you go look at the sample, this one is the deploying a program to a CICS region sample. If you look in host vars in here, you'll see these are all documented as well. It'll tell you, so rather than I had to type in my host name before, this has the host name in, has the port in, has whether it's HTTP or HTTPS, context and scope for CPSM, and then the information that's relevant to this sample. So what we have is the build systems output PDS, and then our load library for my CICS region, and the name of the program. So that's going to serve as the name of the member that I want to copy from this data set to this data set, and the name of the program that I want to run a new copy or a phase in against in my CICS region. So first thing we do is we copy this parameter program from the build data set to the target load library using the ZOS copy command from the ZOS core collection. You can use ZOS copy to copy between your local laptop and ZOS, between ZOS and your laptop, or between two different files on ZOS as well. So you can do kind of the whole gamut of copies between systems that you can imagine. So you can use ZOS copy to push information to ZOS, pull information from ZOS, or move information between datasets and Unix system services on ZOS as well. And then we're going to use the CMCI action module from the CICS collection to run our new copy. So this looks very similar to how we configured the get operation before, except we're running against a different type. This is program, so that's program in capital letters, as you may have seen it elsewhere. Again, we have to use the CMCI resource name, and once again, that is in the documentation. So context and scope, host and port, same as you'd put in CICS Explorer, and the scheme, and then our action name. You have to know the name of the action you're going to run. There's no kind of templating for this. So we're going to run a new copy, and we're filtering our request here to identify only the specific program. So we're only going to new copy one program in my CICS region identified by this context and scope. So if I change into that directory and I try running this playbook, which is called deploy program, what you'll see here, this looks a little bit different to the last command I ran. This one actually has the -i argument as well, because we're going to specify the name of the inventory. There is a default inventory name. If you call your inventory, then you don't have to specify anything. That has the YAML extension. This one isn't going to prompt me for anything. First thing it's going to do is run that copy from the build data set to my load library. Then it's going to run the CMCI action module to new copy that program in CICS. and it tells me it's updated. If I was to go have a look in something like CICS Explorer now, I'd see the new copy count for that program have gone up. And the next time I ran that program, I would have access to the newest version of that load module. So that is our deploy program sample. I'm kind of running out of time to go through any other demos here. The last thing I think I'll leave you with is there's a really good consolidated documentation site for all of the Ansible content for ZOS. So if you Google for Z Ansible collections doc, you'll find this website. This has all of the documentation for all of the ZOS Ansible modules. So if you're interested in what you could automate with Ansible for ZOS, this is a really good place to start. It has the documentation for the ZOS core collection, so you can find all the modules that you can run there, allocating data sets, copying information around, pulling information from ZOS, getting job output, querying job status, etc., etc. There are lots of really powerful modules in there. You can find all the documentation for our CICS collection, so you can come into here and see the modules that we have. So we've seen the CMCI get and CMCI action. This will direct you to the right parts of the CICS documentation to find out about those as well. And the links to all of these are in the slides. So Trevor will send you the slides out. And there are some links to all of the websites that I've shown in there as well, including how to get to our samples. Thank you very much for listening. I'm happy to hang around for any questions.
Okay, smashing. Thanks, Stu. Yeah, in fact, I won't send them out. I'll be putting them on the website so people can download them. So yeah, if you do have any questions, then just type them into the chat and I'll read them out if Stu can't see them, but I'll probably read them out anyway. We've got thanks, Stewart, from Jose Antonio Romero. Anyone else got any questions coming up? All right, here we are from Lakshmi Punya Savali. I can't read the whole name, it's disappeared. Can we integrate Jenkins to invoke the Ansible Playbook?
Yes, you can. So there is a Jenkins plugin that you can install, which will let you run Ansible playbooks from Jenkins as well. I guess I would say it'll provide you a similar sort of playbooks as a service type experience that you'll get from Ansible Tower, although because Ansible Tower, its lingua franca is Ansible playbooks, so it's a bit more designed to do that, but you certainly can use other kind of job runners like Jenkins to do things to run Ansible automation. There is actually a Jenkins plugin for doing that too. Yes.
Okay, thank you. Anyone else got any questions? No, but we've got a comment from Marcus Fitzhugh. He says that was a 5-star presentation. So
thank you very much. I'm glad you enjoyed it.
Yeah, nice bit of feedback. Thank you for that. I will move on then. If anyone else has any questions, you can send them to me. My email address will come up in a minute, I'm sure, and I'll pass them on to Stewart, who I'm sure will get back to you fairly promptly. So yes, so, as we're a virtual user group, can you assume that you're getting a virtual round of applause at the moment, Stewart? Yeah, we've got another thank you from Dina Deutsch. Says, thank you so much. Will the recorded presentation be available? Yes, it definitely will. So hopefully it'll be available later tonight, but sometimes the website's actually slower updating the public facing side, so it'll be there tomorrow. So there'll be the actual presentation that Stu sent through, and there'll be the recording. They'll all be on our website, so just have a look there. Okay, let me share my screen again. Here we go. Right, yeah, thanks, Stu. That really was brilliant. Okay, let's move on to news. And I guess you all know, but it's there anyway. 6.1 is now GA'd. So that was 17th of June that came out. New features in CICS 6.1, together with interactions with other products, are grouped under 3 themes. There's enhanced developer productivity, e.g. support for Java 11 on Z, Jakarta EE 9.1, Eclipse Micro Profile 5, and Node.js 16. Secondly, there's improved security and compliance management. And thirdly, there's reduced cost of management. And the link to the story is on our website, so you can get more information if you haven't seen it already. Oops. Oh. No, I've lost my, yeah, no, I've lost the slide. So as for articles, then we've got organizing CICS regions into Amigamon monitoring CICSplexes, which is by Israel Gross, and that's on the IBM Z and Linux One community website. Oh, sorry about that. Don't know why I'm missing a slide. Plan for the future then. Our next meeting, that's the 13th of September, and we've got Russ Tubner, CEO and co-founder at Hostbridge, and he's going to be discussing the impact of macros on CICS workloads. And the meeting after that is 15th of November, and we've got Israel Gross, who's Principal Solutions Advisor at Rocket Software. That's not the final title. So my holding title is using Amigamon with CICS, but Israel will give us a better title than that nearer the time. Just to remind you, we are looking for a new co-sponsor. So if you work for a vendor and you think that this would be a good user group to co-sponsor, then please let me know. There's my email address. And just a reminder that you can keep up to date with what's happening in the world of CICS and on the virtual CICS user group website by following us on Facebook and Twitter, and by joining the virtual CICS group on LinkedIn. The URLs are on screen, but I don't expect you to copy those down. They're all on our website. They're all on the homepage. Yeah, like us on Facebook. Everyone likes, and use the hashtag virtual CICS. And if you tweet or Insta or whatever, I've got the YouTube logo there as well. Just to remind you, we do have a YouTube channel, and apparently if we get 100 people to subscribe, we can give it a sensible name rather than at the moment it's got some long numeric. So if you do follow the link on our website to the recording, then, like I say, subscribe to it. That would be brilliant. Thank you. Okay, so that's all for this meeting of the virtual CICS user group. Can I thank you all for attending? Thanks to Hostbridge Technology. They're the people who sponsor our user group, make the whole thing possible. And of course, I'd particularly like to thank Stewart Francis for his presentation today. So that's it. Thank you all very much for joining the meeting, and hopefully I'll see you all again on the 13th of September. So thanks and goodbye.